Our next speaker for today is Dr. Rita S. Dhorapkar, Senior Technical Officer, Director's Research Cell, CSIR, NIRI. She is involved in the pilot project, National Mission for Clean Ganga, as a member of the Technical Monitoring Committee. Her areas of interest are water and wastewater management. She has 2 patents, 3 design registrations, and more than 60 publications in national and international peer-reviewed journals. She has provided consultancy to various industries and is currently the Indian coordinator for Indo-EU Horizon 2020 project. She has a number of collaborations, including 12 EU Pani Water Collaborators, International Collaborative Project with Ulster University, awarded by Royal Society, UK, and EP-SRC GCRF joint project with University of Liverpool. We welcome on stage Dr. Rita S. Dhorapkar.
Good evening, and thank you for the introduction. I thank ISOLA, Delhi chapter, for calling me over here, and Himalaya Fountains for putting across to our director, who has marked it to me. So it's my duty to be here. So, well, thank you very much for my previous speaker, and thanks for putting her first, because it makes my job much easier, because she has introduced many things which I wouldn't, because I am here representing CSIR NIRI, and I'm more keen to introduce NIRI to you and its technologies. So when we're talking about sewage treatment technologies for reuse of treated water, I'm sure that you are aware that the NGT has revised the orders for sewage treatment and the standards that we should meet in metro cities. And wherever you will dispose, it is not that if you dispose on land, there is a different standard, or if you're going to a coastal area, it's a different standard. It has become one standard, and it's very strict. The reason being, what the NGT order says is that our water bodies are getting polluted because of sewage, and that is the major cause, and it is now in a written order. So we are going to have revised standards, and all the metro city people will have to revise their sewage treatment plants. Okay. So, well, NIRI was established in 1958 when there was an epidemic of jaundice, and it was called as the Central Public Health Engineering Research Institute. As it grew from 1958 to 1974, when Indira Gandhi visited and she saw the varied mandate of NIRI as it has grown, she decided to call it the National Environmental Engineering Research Institute. This is a part of the CSIR, the Council of Scientific and Industrial Research, New Delhi. Its headquarters is New Delhi. And we have about 38 labs spread across NIRI, across India, and NIRI is just one of them. So what does NIRI do? NIRI has wastewater treatment. These are the various sections that are present inside NIRI, and it encompasses almost all the aspects of environment. So wastewater treatment, clean air, environmental systems and modeling, environmental biotechnology, environmental materials, environmental impact and risk assessment that we perform for various industries, environmental health, which is becoming a very important part of the study of the impact of the various pollutants on the health of the individual, environmental genomics. We try to have modified, or not modified is the wrong word. We try to see which bacteria is important in which scenario and which will work more effectively for the whichever treatment we are carrying on for wastewater or air, whatever. We have the clean water. These are the various sections in NIRI. And I think I'll skip this slide because it will take more time. So the significant achievements, we have scientists who are staff strength of 292, 104 scientists, 35 technical, and 52 supporting staff. And we have a number of projects, technologies, we have active MOU, we have publications, patents, scientists and students. Nowadays, there's a lot of importance on, training students, and there are many students who come for internship to our CSR labs, and they are being welcomed. And I saw many students here, so I thought I will say that. And our institute is open to anyone who is interested in visiting and taking a project on environment. And we have a number of design registrations and outreach and training program. So we have a pan-India presence, and we have 5 zonal labs. The orange dots that you see on the India map, they are our zonal laboratories. Our headquarters is placed in Nagpur, that is where I am coming from. So we have a clientele of state and municipal agencies, central and public sector agencies, state and public sector agencies, private sector, foreign, central government, and a lot of cases which come through the court to NEERI for verification, and through the National Green Tribunal. So we have a lot of international partnerships as well. How we contribute to India's national mission is by Namami Gange. We have done the special properties of River Ganga. We have monitored the river water quality right from Gangotri down to Varanasi. We have done river rejuvenation through natural treatment systems. I'll be talking more on this. For Swachh Bharat, we have installed electrolytic defluoridation plants, iron removal plants, phytorid natural water treatment technologies, which I'll be talking in a little detail, rapid composting, which I'll be introducing to you, menstrual waste management technologies. Then Swasth Bharat, we again have phytorid for sewage treatment, air pollution control and health benefits, solar water disinfection, I'll introduce very shortly. Electrolytic defluoridation, again iron removal, chemo defluoridation, improved multi-fuel cook stove. Smart cities, we have done water safety plans, lake restoration, wastewater for recycle reuse, plantation for degraded lands. National Green Highway Mission, recently given to us by Mr. Gadkari. We have strategically designed the green belt development on the national highway from our city to Wardha. The technologies which are commercialized are the phytorid, the renew I'll be talking in detail with you. We have the improved firecrackers for reduced emissions that was applauded very well across India, and we have more than 150 companies which have signed MOU, because these improved firecrackers are also patented, and it reduces emission by 30% on the existing. So all the firecracker companies are coming and having MOU with us. So, and then of course the solar energy based electrolytic defluoridation, its presence is felt pan India. The Nirdhur is the domestic multi-fuel cook stove, and many of us know that rural India, the women suffer a lot because of the cooking conditions, and they use the stoves which are not very efficient in fuel utilization. The Vayu, that is the big augmentation purifying unit. We have the strategically designed green belt and along highway, and its performance evaluation towards eco capital build-up. So it's not just designing it, but also having studied the after effect. And the green dispo, which is an improved eco-friendly and energy-efficient electric sanitary pad incinerator. This is our work towards the menstrual waste problem solving. Now I come to the phytorid technology for sewage and wastewater and rejuvenation of water bodies. Now this is a licensed technology, this is a patented technology of NEERI, and it is now felt like everybody who is working in the wastewater treatment knows about phytorid. And it's a modification of constructed wetland technology. The basic concept is removal of pollutants in wastewater with the help of plants. The basic units are sedimentation tank, planted bed, phytorid chamber, and treated water collection tank. It's a system where aerobic and anaerobic treatment happens in one sewage treatment plant. So anaerobic means biological treatment without the presence of air, and aerobic means what happens in the presence of air. So both kind of bacteria. This is a schematic of the phytorid system. As you can see, the sewage over here is fed into the sump, which goes to the settling tank. This is necessary for settling and sedimentation of the the solids which are settleable, and then it goes to the phytorid bed, which is consisting of subsurface flow, and it has a layered scientifically layered bed it is, and then the overflow goes to a treated water tank, and further it is disinfected, and it can be reused for irrigation in garden and farms. Nowadays we are also introducing adsorption beds. After this we have a sand and activated carbon to meet the norms, the new norms that are coming in place with this NGT order. So it has a negligible maintenance cost, and it looks like a landscape and garden, and complies with the regulation laid by the Pollution Control Board, and qualifies for green rating credits by IGVC under water deficiencies, and allows use of grey water up to 95%. It can be application areas can be these small colonies, even the apartments, townships that are coming up, hotels, municipal schools, municipal councils, education institutes, schools, colleges, railway stations, and public toilets. The contaminant removal mechanism in phytorid is the biochemical oxygen demand of organics, which is reduced, nitrification and denitrification, and the phosphate uptake, which is taking place by the plants itself. And the anaerobic treatment zones are at the bottom. So BOD reduction is because mainly in any STP, the BOD is the measure of organics in the wastewater which are biodegradable, and this is the parameter which is of prime importance while you're designing, or even in the treated effluent you have to measure this, and this is the parameter which I was saying is now less than 10 as per the NGT order. So BOD reduction is because of the oxygen diffusion in liquid, and that is the liquid limiting factor in any STP, and that is what controls the mechanism of removal of BOD. So what kind of plants that we can put on the bed of the phytorid are the bulrush, the nutsedge, the canna, the cattails. And this is a picture of the plant of the phytorid plant which is existing in Mahindra Igatpuri. It's of 60 cubic meters per day. And this is what it looks like. When you see the influent and effluent, you can see the clarity in the water, and it meets the standard of the suspended solids, the COD, BOD, nitrogen, and phosphorus. So this is this is the phytorid plant at Siemens Kalwa Works, another one at the Baramati. This one is at Pune. This is at Mahabaleshwar. This is at Chakan. And we have also installed phytorid plant at the Godavari River, where we saw the drains were carrying sewage and meeting the river, so it was diverted into a phytorid wastewater treatment plant before it met the Godavari. So what is the area that is required for phytorid is, you can see it is 1200 square meters per MLD, And it's comparative to the other technology. ASP is activated sludge, membrane bioreactor, there is a sequence bioreactor, then moving bed bioreactor is also there. And when you compare all this in the table, the phytorid is having a 1200 square meters, which is comparative to the other technologies. But when you compare to the cost, the cost is much less, and it is about 75 to 80 lakhs, and percentage of that as a percent of the capital cost is actually in the civil cost and the biomedia and plantation, and the operation and maintenance is almost 40 times less than the other technologies. So rejuvenation of water bodies, we come to another solution is flow raft. Of course, the first step which you have to do for any water body is to stop primarily any sewage inflow into the water body. If that continues to flow, then any amount of technology that you use, it will not be able to rejuvenate the water body. So when apart from that, there is something called flow rafters, which is also a needy solution. And this principle behind the flow raft is that the biofilm of these plants covers the island and the plant roots, and these are able to take up the organics as well as the nitrogen and phosphorus and rejuvenate the water body. So it looks like this, and it is quite ornamental. It is already in Telibanda Lake, and in Mumbai in 2-3 lakes we have already put that. And you can see here the Makhmali Lake, the Siddheshwar Lake in Thane, the Davala Lake and Dativali Lake, where these flow rafters have been put. We come to enhance in situ drain treatment, which we were talking about. Ma'am has just shown you what is the problem when you have the drains and it is not monitored, and it is a no man's land actually, and the slums and the dhobi ghats and everyone just thinks that it is a place where you can dump your solid waste or liquid waste, or even the cow dung, or even anything. We have experienced all kinds of things, and so we were very fortunate that we were given a project in Prayagraj where we have installed this in 6 drains. And it all started in Niri with a dream of our director, Dr. Rakesh Kumar, who wanted to see this drain which was running inside Niri to be converted into, treated, and then if we could use the water which was treated for the plants inside our Niri. So it was a pilot plant which was run successfully, and we named it as Restoration of Nala with ecological units, and its name is Renew. So I will not talk about the background and need for treatment. Ma'am has already talked about it. And so in Jhansi, Prayagraj, we got an opportunity when our head of directors research cell went to present actually something else, and very shortly she talked about Renew. And the NMCG person said that, can you demonstrate it? So she said, okay. So how many drains you will take? So she said 1. So he said, I'll give you 6. So that's how we got that project. And I remember when she came back and we were sitting as a team, and we didn't know whether to be excited about it or be scared, because it was one of a kind. It was really one of a kind. So, and we had run that as a real pilot plant, and then of course we got the courage and we went through it. And these are the 6 drains, and as you can see, we use the drain as the treatment chamber. There's no land requirement. As the drain flows, we have constructed our engineering units according to the topography. The topography and the detailed project report is a very important integral part of this work. And because the flow of the water in the drain has to be captured in such a way that we can design our units. So we don't dredge it or do anything. We just convert the existing drain into a treatment system. So what are the units that we have? It's just like an STP. We have the screen and grid chamber, then we have the sedimentation tank. We have introduced anoxic tank over here, which is a wonder and it works very well. Then there are biocurtains. We have specially designed microbiological solution which is put on these curtains and it is introduced into the drain and it is hanging on top. It's like a biocurtain. And then we have the flow raft and the phytotraps. And then in the last unit, just as the treatment water flows out, we give a chlorine contact time of we give it about half an hour, and then it is allowed to flow into the river. So we don't have any microorganisms also flowing out of this drain. So these are some of the pictures, and I forgot to say there is an aeration unit also, and it's absolutely natural because it is going to run on the solar panels. And there is flow rafts that are using the same plants that we are using in the phytorid also. And then we have the bar screens you can see down on the extreme left. And you can see the picture of before and after cleanup, how beautiful it looks. So we have, in this we promise about 60% reduction in BOD. We are not promising 10 BOD here. We are saying that if we do the treatments of this, because there is no, we can't predict what will come in the drain. So there is no like equalization, and sometimes suddenly there is a shock load because some dhobi has done something, or some cattle people have thrown their dung into this. So we promise about 50 to 60% reduction in BOD, and definitely in suspended solids we are saying that we will get about 90% removal of the suspended solids. And this drains was monitored by another institute. It was not done by us, for National Mission of Clean Ganga, and it was open to the public, that all the results, and we got 20 BOD. So that was the success story. This is over there. Yeah. It is about 120 or sometimes 210. It depends. It depends from time to time. It is a public document and it is present on the IITR website, Lucknow. So this was of course tweeted by Nitin Gadkari ji, so we like to put it in our presentation. And this is the renew that is existing already in Niri. So this is the project which I have now. It is a DST sponsored Pani Water project. I just wanted to put it over here because apart from the contaminants which we talk about, there are contaminants which are not visible, and which are contaminants which are not being regulated, and these are the contaminants of emerging concern. They are called CECs. And what are they? They are antibiotics, pharmaceuticals, they are the personal care products, they are endocrine disruptors, there are steroids, hormones. These effects on the health of all these contaminants is not known, but they can give you an antibiotic resistance in the body, which is why people don't react to the antibiotic doses which they were reacting to previously. We require higher doses. It gives more opportunity for the drug industries to, have more business now. So what we are, in this project, what we are seeing is that we monitor and map the sewage treatment plants and the treated water from the sewage treatment plants, which are going into the inland surface water for these contaminants of emerging concern. And we come up with a solution by using advanced treatment and provide water sans CEC. Many people talk about organic farming, and organic farming is, we think it's safe. Why? Because people are using the right water for irrigation. But all of us know where our vegetables come from. You go to Keshavpur in Delhi, केशवपुर पानी पूरा ड्रेन में जा रहा है, and after 10 kilometers is going to your farm where your vegetables are coming back to you. So if we have these contaminants of emerging concern in the sewage, treated sewage, they are leading to bioaccumulation in the crops and food produce, which is why we say that if we want to reuse the treated water for irrigation, then we should have an additional treatment, which is what we are working on. And as you can see, we have this association with Aquasoil Italy and also Spain and many countries. And in this association, we are co-creating a technology called Mitox. And we are looking actually for a demonstration site. It will be 100 meter cubes per day, and the amount of land that we require for that will be about 10 by 10 meters. That's it. So if anyone is interested, please contact me. So yeah, it is an integrated decentralized treatment which will consist of coagulation, sedimentation, ozonation, and hydrogen peroxide. And the treated water we promise, which we will promise, it will be fit for agricultural reuse, and it will be a very low maintenance and low electricity consumption, and it will also have reduced sludge volume. So drinking water technologies I'll not talk about, and so this is what it will look like, the demo plant. And yeah, just 1 minute I will take for this one. This is a solar disinfection for potable water. This was a fast-track translational project which we got from CSIR. This is a work of about 10 years done by Niri, and we have come up with a solution where water can be disinfected by solar radiation in this plant and provide about 100 liters per day. And this runs on its own. So it will be microbiologically safe, and it will be having no SS. These are the 2 units we promise, 2 parameters we promise by this. And what we have seen in rural areas, normally water is okay except the microbiological contamination. So these units are available, and this technology already patented, and it is also available for licensing. Okay, thank you.